Hi students, the previous video we seen about the some of the data handling functions. Those are nothing but skip function, master control relay function, and jump function. However, the jump function will be further classified into jump with return and jump with non-return. So in this video, I want to teach about the remaining data handling functions. Those are nothing but move function and what are the various types in the move functions and FIFO first input first output and FAL finite arithmetic logic function and CLR function and ONS function means one shot function and sweep function in this video. So our first topic is move function. So what is the need of the move function means suppose if you want to transfer any data from the one register to another register, then we prefer for the move function. So the syntax for the move function is this one. So here we have source and destination. So in the source we can represent one register and in the destination we can represent the another register. So when we make the enable input on, that means IN0019 is on, then the data present in the source will be transferred to the data present in the destination register. That means from IR0107 to the OR1123. So when the complete transfer of the data completed, then the move function, then the output coil at the move function can be can be makes on. So this is the syntax for the move function. So we can observe this move function application with two examples. So first example is one timer is there. So on the timer what happened, we have the preset value. So based upon the preset value the timer will be operates for some time. So here our programming is we can make the preset time frequently. That means if you press one contact, then some time will be allocated. That means 7 seconds will be allocated. 7 seconds will be allocated. And if we press the another contact input, then the 15 seconds will be allocated on the same timer. So for that we consider the one register HR0051 for 7 seconds input, and we consider the another register that is HR0052 for the another time setup that is 15 seconds time setup. So the ladder diagram for this one is in this manner. So here we have two move functions. This one is the one move function and this one is the move function. And how we said means here we have the source and destination. So many syntaxes also have the source and destination. Then how we can identify whether this one is a move function or a arithmetic function means by observing the prefix at the output coil. So here in this output coil we have the prefix as MV. MV means move 0071. So here we have the one register. That register is nothing but HR0051 and the register value will be transferred to the which register, HR0101. And in the similar fashion, here also we have the another register that is the HR0052 and the data present in the HR0052 register is also transferred to the which register, HR0101 itself. Then what happened? The which data, that means in this HR0051 we have the 7 seconds and HR0052 you have the 15 seconds. So which seconds, that means 7 seconds are entered or 15 seconds are entered will be decided by these inputs, enable inputs IN007 and IN008. If we press the IN008 on, then the data present in the HR0051 will be transferred to the HR0101. So this HR0101 register will be present as the preset value for the timer circuit. So with this preset value, the timer will be operated. And if the IN008 is on, then the data present in the HR0052 will be transferred to the HR0101. Then the data will be transferred from this register to this register, and this HR0101 register as the set as the preset value for the timer. So 15 seconds will be set as the preset value for this timer function. Okay, in two ways we can set the preset value. That means one is the 7 seconds and the another one is the 15 seconds. So 7 seconds or 15 seconds are decided by the IN007 and IN008 inputs, but here our intention is how the data will be transferred from one register to another register. Why? Because now we are discussing about the move function, not the timer function and not the enable input. We can observe the move function, and here we have the another two contacts. These contacts are nothing but interlocks. So what is the use of the interlocks means, once we send the data from the HR0051 to the HR0101, then there is no need to transfer the data from the HR0052 to the same HR0101. So in order to stop the one register data while working with another register data, we have to provide the interlinks. That means, suppose if IN007 is on, then this contact will be on. So when this contact will be on, wherever these contacts are present, sorry, this coil will be on. So whenever this coil will be on, then wherever the contacts present at the movie MV0071 will be on, and those will be converted as a normally open contact can be converted as a normally closed contacts, and normally closed contacts can be converted as a normally open contacts. So here we have the normally closed contact. So this normally closed contact will be open. Then this does not allows the data from the HR0052. Why? Because there is no contact for the this particular move function. So in this manner, in order to provide the interlocks only, we can put the this MV0072 and MV0071. And let us see the another example. So what is another example means, addition function. So you have four registers. That means IR0041 and IR0042 and IR0051 and IR0052. So here what is our example means, the data in the IR0041 and the data in the IR0051 will be added, and the result will be stored in the OR006. And similarly, the data in the IR0042 and the data in the IR0052 will be added, and the data will be stored in the OR007. That means what we do, first we have to transfer the data, and we can add the data, and the result will also stored in the another register. How we do, let us see. So here this IN008, this IN008 and this IN007 and this IN007s are for interlock purpose. That means once one is operating, then remaining are off purpose. So suppose if IN007 is on, then what happened? IR0041 register value will be transferred to the HR0142 register. When the moving completed, this output coil will be on. And when the IN007 is on, IR0042 data will be transferred to the HR0143. So here in the arithmetic function, you have two holding registers, HR0142 and HR0143. Then what values present at now? HR0142 and HR0143, IR0041 value and IR0042 value present now, and it performs the addition operation and sends this data HR0144 data to the OR006. OR006. Why? Because here we have the IN017, IN017, IN007, sorry, IN017, and here IN007, and here IN007. And similarly, if we want to transfer the data from the IR0051 and IR0052, we can go for the contact as IN008. So with that IN008, the data in the IR0051 will be transferred to the HR0142, and IR0052 data will be transferred to the HR0143, and the addition will be performed, and the result will be stored in the HR0144, and this data will be transferred to the this register OR0007. So in this we can transfer the data. So like the move functions also, we have some other move functions are there. What are those some other move functions means? Block transfer move function or table to table move function, and second one is table to register move function, and third one is register to table move function. So what is the use of the block transfer function means, suppose every function transfer the data 16 bits at a time. Every move function transfer the data 16 bits at a time. So here one register is there, and if you connect the one move function to this one, then this 16 bits will be transferred to the this register OR0128, and the second one IR0054 data will be transferred to the OR0127. Like that, suppose if you want to transfer the 147 bits at a time, 147 bits at a time, then how many move functions we required? 10 move functions we required. Why? Because every register sends the 16 bits, so 16 into 9 144, so 144 bits will be transferred through the 9 registers, and the remaining 3 bits can be transferred with the help of the last register, that is nothing but 10th register. So for transferring the 147 bits, we can use 10 registers. But without using 10 registers, we can transfer the total data by using single register. That single register is nothing but single function. Their move functions now also single function. That single function is called as block transfer function. Block transfer function. So this function, syntax for this function is length. That means how many registers we consider. So how many registers we consider? 10 registers, that can be represented with 10. And source n means from what registers to, we want to transfer the data. That means these are on those registers, what is the last one. Some functions have source start and destination start also. So this particular register, this particular function, block transfer function, we have n registers. So in the source side, what is the end register? IN0062 register, and destination registers end. So what are the destination registers end? OR0137. So last register is IR0062 and OR0137, and how many registers we have? 10 registers. And when this will work? When the enable input is on, and when this output will be on, when the complete transferring of the data of the 10 registers will be completed, then this output of the block transfer register will be, block transfer function will be on. And next one, table to register function. That means some some block of registers data will be transferred to a single register, then that function is called as table to register function. So here we want to transfer the OR0034 register and OR0035 register and OR0036 register and OR0037 register, and from these registers we want to transfer the data to the single register. That single register is nothing but HR0172. HR0172. Then what is the syntax for that one is this one. So here we have the one reset input and one enable input, and here we have the one input, that means enable input or step input. This will be on for every register. That means in the length you have 10 registers, so this must be on for 10 times. For that purpose, we can provide one retentive clock here. And in the similar fashion here also, here we have 4 registers data we want to transfer to the single register. So here the length is 4. And what is the our source registers? How many registers are there? 4 registers. So among those 4 registers, what is the last one? End one. We may put the either starting one or end one. So at this particular syntax, we have the end one. So that's why I represent the end itself. So what are the end register? OR0037. And what is the destination register? HR0172. And then what about the pointer? The pointer is nothing but HR011 register is there on the register in the middle of the transferring of the data. At what register our operation is now, we want to see, then we go for the pointer register. The pointer register is nothing but HR0100. That will give the how many bits present at that particular time. And after the transferring of the data from these 4 registers to single register is completed, then this particular output coil will be on. In the similar fashion, we can transfer the single register data to a table of registers data. So the representation is in this manner. So the data present in the HR013 is transferred to first one register and then one register and then one register. So totally we want to transfer to the three registers. So in the syntax is same as that of the previous one. That means table to register function. So here also we have reset function and enable function and step. The step will be what is the length indicates that many times this will be on. So here we want to transfer the data to the three registers. So we consider length as the 3, and what is the end register OR0164, and what is the destination register, that means source register HR0173, and the pointer indicates at what register or at what value now we transferring. And after the completing of the transferring the data to the all these three registers, then the output coil at the this RT function will be on. In addition to these functions also, some other functions are there. Those functions are nothing but number of other special functions. Those are for the Omeran software we have move not function, and for the Culter Hammer function we have the fmove function, and for Alan Bradley block transfer read and block transfer write also there, and for Modicon PLC SRCH, that means search and block to table BLKT, and table to block, that means TBLK, and indirect block read IBKR, and IBKW, that means indirect block write, like that. So many other PLCs have also other move functions. So this is about the move function, and in addition to the move function we have the some other data handling functions are also there. Those are nothing but FIFO, first input and first output, and FAL, file arithmetic and logic, and ONS, one shot function, and CLR, clear function, and sweep function. So that one is FIFO function, that means first input and first output. So first input and first output means we want to put the data or we want to take out the data from a stack. So for that in our PLC we have two blocks. One is for FIFO load and another is for FIFO unload. That means in order to put data we use the FIFO load command, and in order to take the data from the stack we have to use the FIFO unload. Sometimes it may be represented as F in, and sometimes it may be represented as F out. So in this we have to represent the some data. So F load means take the data from the any stack. So that's why we have to know the what is the source and what is the length of the data we want to take, and some another command, that means control, position, etc. And in the similar fashion when we unload the data, then we have to consider the destination to which register we have to send the data present in the stack, and what is the length of that present data, and some position and control all other. So these are the syntaxes for input, that means for loading FIFO load, for unloading we go for the FIFO unload. And what is the use of this one means source means the location of the next in source word, and FIFO means loading first input and first output, and destination means to what locations we have to send the data, and control we also have, and position we also have, and the length means maximum number of words that can be load in a single FIFO. And FAL means this can be perform the complete or continuous compute function means to perform the any arithmetic operation we go for the compute function. So if you want to perform the different values in a cyclic manner, then we go for the finite, file, arithmetic, and logical function. So here also we have the position and length of the bit and destination, and what is the expression, by using what expression we have to solve that one. So different operations we can perform. So what are those operations means we can copy the data, and we can clear the data, and we can do some arithmetic operations, and we can do some boolean operations, and we have to do some the conversions also. So while copying there is no operator, copy from the data from A to B, and clear means set a value to the 0, and arithmetic means plus, minus, into, and divided by, and negative means bar, square means SQR, and exponential means 2 dots, and bitwise means AND operation, OR operation, XOR operation, and NOT operation, And conversion means BCD to binary and binary to BCD. The commands used are this one, FRD and TOD. And in addition to these functions, some other functions are there. Those functions are nothing but ONS function and CLR function and sweep function. So what is the use of the ONS function means when the switch will be on or off at particular condition. So sometimes because of this on or off, some of the voltage spikes will be present between the on condition and off condition. So at that time, even though that switch is off position, then because of some small misoperation of the miss spikes, then that particular switch may be considered as a on contact. Because of that on contact, the program may be changed. So in order to stop those contacts, we can provide the one shot button. This one shot button eliminates the spikes present between the 0 to 1. And the clear function. So this clear function used to set the all bits in a register to 0. And sweep function. Sweep function means in order to scanning our program, we have to go for the sweep function. And always we wish to scan the sweep function. The scan time must be less than the sweep time. Then only the scanning will be possible. Otherwise, we may not get the proper scanning. And the sweep function is used when you wish to scan through a program or a portion of the program at fixed intervals. So with this, we completed the data handling functions. In the next video, we will see about the bit pattern in a register and bit shift in a register and sequencer functions in the next video.